Truth be told, Unity has an excellent built-in pathfinding system using the navigation tools. It's very possible you have experience using navmesh agents and navmeshes to move your characters around. If you're happy using Unity's navigation window and don't really want to be bothered with how these algorithms work, then stop right now. There's no need to take this course. We're discussing something that is already implemented in Unity and generally implemented pretty well. Unfortunately, while the navigation tools are terrific, if they're your only experience with pathfinding, then you've become somewhat reliant on a black box to calculate your paths through the game environment, and that's a bad thing. We want to demystify the underlying theory that enables pathfinding, and we should point out that the algorithms that we discuss have more applications, but in our specific case, we'll be examining a two-dimensional array of grid squares on the XZ plane to figure out how to travel from one point on the plane to another. What we're looking at today are called graph and tree search algorithms. If you look on Wikipedia, you can see there are quite a lot of them, but we're only going to be sampling a handful. The A-star search algorithm is likely the one that you've heard tossed around in discussions about game development, and that's what we're eventually going to end up with. Let's go through a little bit of terminology first. In mathematics and computer science, a graph is some structure of objects that are related or connected to one another. The graph is this whole structure of objects, and each object in the graph is called a node, also commonly called a vertex or a point. The connections between the nodes are called edges, and you may also see them referred to as arcs or lines. We're going to write a tool to search each node or vertex, a process commonly called graph search or graph traversal. Basically, we're trying to figure out how to get from one node to another via the edges. Graphs are just mathematical structures. Any set of objects can be thought of as a graph as long as the objects have something defining some kind of relationship between them. The graph itself could be abstract. For example, here's a graph of language contribution in 1 month of Wikipedia usage. The graph is really just something to help us visualize some data. In our course, the nodes will correspond to physical positions on a map, and the relationship connecting them is defined by distance and proximity. Pathfinding over map is a very common usage of graph search. We can represent the map of our environment as a series of nodes connected by lines or edges. Wherever there is a wall, we mark those grid squares as blocked or obstructed, and keeping things simple, everywhere there isn't a wall, we just drop open nodes and then just connect them together. When you look at the sum total of all your nodes, you end up creating a graph that looks like this. Each cell of the grid will be one node, so let's make a basic class to handle our node in the next lesson.